Welcome to Study Loop.
Hello everyone, so today we're doing chapter 17, problem 8, and this problem gives us two molecules, A and B, and it asks us that which compound has a larger heat of hydrogenation when both of these are hydrogenated to methylcyclohexane? Which of these are more stable? So we know that the less stable compound is going to have the larger heat of hydrogenation. So it means that the less stable one is going to have require a larger change of enthalpy when we want to add that methyl group to our cyclohexane. So what we know is that when we have less stable, we have a larger delta H value change. So now we need to determine which one of these are more stable. So how do we do that? Well, we know that aromatic structures, or structures that are fully conjugated, are more stable than the same number of carbon atom structure that is not conjugated. So what does that mean by conjugation? That means that every single one of these carbons are involved in a double bond. Another way of thinking that is that when you have conjugation, not only is every one of these carbons involved in a double bond, but every one of these carbons is what we call an sp2 carbon. So now we see that we have 6 conjugated carbons here. Well, what about this molecule? Well, we have only 5 carbons now that are involved in formation of double bonds. This carbon here is an sp3 carbon. So we actually have 2 degrees or 2 double bonds in this cyclical structure, while here we have 3 double bonds. So right off the bat, we know that we have a higher grade of conjugation in the cyclical structure than in B. And secondly, we know that we have 6 sp2 carbons in A, while in B we only have 5 sp2 carbons. So we have 5 sp2. So right off the bat, we know that A is going to be more stable than B. Not only that, A is essentially a benzene ring, and we know that benzene is highly stable, more so than some sort of cyclohexene, such as in B. So we know that because A is a benzene ring, it's going to be more stable, so that means it's going to have a smaller delta H value. But the B is just some sort of cyclical structure with alkene double bonds in it that are not conjugated. We know that B it's not a benzene ring, so it's going to be less stable, so it's going to have a higher delta H value.